So, hello everyone. Today, Stella Sifo and Natalie Charbel will be presenting this session. So, Natalie and Stella, over to you.
Thank you very much, and hello everyone. I hope you're enjoying the conference so far. So for the next 30 minutes, Natalie and I are going to guide you through the neo4j-graphrag Python package, and more specifically, how you can use it to build a knowledge graph from unstructured data. So what is this about? So yeah, the Python package, as I said, has two features. Let's say mainly one is the graphrag part. So we have several retrievers, and the other one is the knowledge graph construction. So you can find here some links to the repo, the package, the documentation, and one of the latest blog posts that we have. We can copy that in the chat if you want to. So this package, for the two aspects, we have on the KG builder side, we have built a low-level pipeline architecture with low-level components that you can connect to each other and define the data flow between those components. And we have one, let's say, template pipeline that can be used specifically for knowledge graph construction, which is called simple KG pipeline. You can customize a lot of things in this pipeline, but not everything. And for GraphRag, we have the same principle and the same thing, for instance, for the LLM or the embedder that you want to use. So the simple KG builder pipeline that we have actually implements all of those components. So each box is a component, and it has one or more implementation depending on the component. And each of them can be customized, so you can implement your own component if the one that we are providing in the package doesn't match your needs. We will see a demo about that later on. So I'm just going to go through each of those components very quickly so that you understand what's going on afterward in the demo. So the first component that we have, so the document is usually a PDF document, so some unstructured data. The first thing that we have to do is to extract text from this component. So that's what the data loader is doing. And then we have the text splitter. So the text splitter or the chunker is splitting the text into smaller chunks that can be processed by the LLM and has some semantic meaning. So then another very important part is the schema builder. So this is where we tell the LLM and the whole pipeline afterward what is the graph model that we're expecting? What are the node labels? What are the relationship types? And this is used by the entity and relation extractor. So this is the component that actually performs the entity and relation extraction. So in our implementation in the package, it's relying on an LLM and the schema that comes from the schema builder. Then we also have this lexical graph builder. So lexical graph is what is, it's made of basically the document and your chunks. So that's the information, the raw information about your data before any entity extraction is performed. And this can be used for vector search then when you are in a RAG context. So after we have built this lexical graph and this entity and relation extractor, so the entity graph, we have a step that we call graph pruning. And the graph pruning is basically enforcing the schema with some configuration parameter depending on how confident you are in your schema and how variability you want in your knowledge graph at the end. But we are enforcing, for instance, that node labels that have been hallucinated by the LLM can be removed in that step. And finally, or almost finally, we write this knowledge graph, so both the lexical graph and the entity graph to Neo4j. At that stage, we haven't performed any entity resolution yet. So we will see an example later on. We will have quite a disconnected chunks. But we have a final step with entity resolution where we try to merge entities which are very similar between, even if they appear in different chunks. So with that, I will just leave the stage to Natalie. We will give you a demo of the different features.
Thank you, Estelle. Hello, everyone. So yeah, let me take over and share my screen. So this part of the demo, which is the first part, will show how to use the simple KG pipeline, which is the easiest way and the fastest way to get started to have KG construction feature with our GraphRag Python package. I'm going also to show how by simply using the simple KG pipeline, we can adapt some parameters in order to improve the entity and relationship extraction, such as controlling the schema. So I saw one question about that in the chat, and also updating the prompt to the domain-specific needs. So before we get started, let me just give you an overview of the document that we are using here. So it's a 9-page PDF document that I extracted from Wikipedia. It's talking about climate change. So it has some information about temperature shifts, weather patterns, environmental events and impacts such as extreme weather, temperature rise, sea level rise, and things like that. It also talks about causes of global warming and the causes from greenhouse gases and human activities. It also has some information about agreements used to mitigate climate change and the use of energy, renewable energy source. So this is the document in a nutshell. And I'm going to use it in the simple KG pipeline. So I'm going to run this pipeline with this document. Let me first run the pipeline because it will take a few seconds, and I will explain what we are doing here. So we create an instance of the simple KG pipeline. We have to pass 3 main and required parameters. The first one is the driver, so the neo4j driver instance. So here I'm using a .env file where I store my credentials. I'm using a local DBMS instance. So I'm reading from this file and to instantiate the neo4j driver instance. The second parameter that we need to pass is the LLM interface instance. So we have in our package several LLM interfaces depending on the provider. So we have one which is based on the OpenAI services. So I created an instance of the OpenAI LLM. Here I specify the model name. So I'm using GPT-4o. And we can also specify some model parameters, such as the temperature and the response format to be JSON. The third required parameter is the embedder instance. So again, we have multiple embedding interfaces. I used the one relying on OpenAI and specified the model to be text embedding 3 small. So by running this pipeline on this file path that I have, I can also attach some metadata like the source of the document from Wikipedia. So it took a few seconds. Let's look at the database and see the graph that we created. So I had an empty database in the beginning, but when I run the pipeline, I should have a graph that was created. So this is an overview of the whole graph. We can see that it is split into 2 parts. The first subgraph, which is represented by the gray color, it's the lexical graph that Estelle talked about it. You can zoom in and see. So it has information about the document node. So the type of the document that was used, the path, the metadata that we attach, such as the source. It also includes all the chunks that were extracted. So here it depends on the chunking strategy that we used, but here by just using the default one, we got 7 chunks in general. The lexical graph has information about the relationship between a document and the chunk. So for instance, we have the from chunk relationship. We also have information between chunks. So for instance, the next chunk between 2 chunk nodes. So the interesting part is the green part, because it includes the information about the entities and relationship that were extracted from chunks. So this is the domain subgraph. Maybe let's look at the schema visualization just to see the main nodes that were created. I'm gonna hide all the lexical part just to show the domain entity information that were created. So we see we have a disconnected graph, so it's not the best graph, but we see like relevant information such as the greenhouse gas node, human activities and the relationship between them, the environmental effect or impact, and the region where the impact where it was observed in. So I'm going to show how we can improve the extraction. So this is just by using the default configuration of the simple KG pipeline, but there are a couple of ways to improve it. So just for the sake here of simplicity, I'm going to delete the graph before another pipeline run, because it's easier to spot the new information that was created. So one way to improve the entity extraction is to control the schema. And this is the underlying schema that is used by the LLM to guide it in the extraction of entities and relationship. So there are many possibilities, but the main idea is when we call the simple KG pipeline, we define the pipeline and we run it, we provide the schema that should be used to guide the extraction. So one option is to define a schema from scratch if the user is a graph expert and he knows about the schema. But another way, instead of working from scratch, is to use our schema from text component, which automatically extract the schema from unstructured text using LLM. So we need just to pass the LLM interface instance, and we can run it on the text of the document. So yeah, let's actually run it. And we can also visualize it. So there's the schema visualization feature that we have. So yeah, the user can see the graph of the generated schema, and if they are happy with it, they can use it and pass it directly to the simple KG pipeline. And if not, they can save it. So yeah, we can save it and have it as a JSON file, and we can refine it and improve it. So this is the schema that was extracted by the LLM, which is good overall. It has richer information. So with respect to the schema that we saw previously, there are like the graph is more connected. It has some information, but lacks also other information such as the renewable energy source, for instance. It's not represented here. So what I did is I used this one in order to refine it. So I saved it, I refined it. I will show you what I did basically. So I created other nodes such as the renewable source, the metric node, for instance, to model quantitative indicators about temperature and their units and their values and things like that. Also, some other relationships such as the agreement targeting a climate event and a country participating in this agreement. Yeah, so let's look first at the file that was created initially. So it has this structure. So we have the node types, which is the list of the nodes with their label, description, and list of properties. A list of relationship types, which defines all the relationships in the graph, again with the same information, label, description, and set of properties. And we have a list of patterns, which model the connection between node types via relationship types that were previously defined. So we can change this information. We can add a new relationship, as I did. We can also control some flags which are used later on to enforce the schema after the extraction. So all the nodes and relationship that are created and that are not represented by the schema, they will get pruned after the extraction. But we can also allow them, so we can allow additional node types, relationship types by controlling these flags. So this is an enforcement on the graph level, but we can also set other enforcement flags at the node types and relationship types. So for instance, we can allow additional properties on the relationship and the nodes. We can even have a control on the or at the property level itself. So we can set the property as required. So here, for instance, if it is true, then all the nodes having this label that are generated by the LLM and that do not have the name property will get pruned afterwards. So yeah, this was about the structure of the schema. So I will use now the new schema that is refined and that better represents the domain. I will run the simple KG pipeline again using the same document. Let's see the results. Let's see if the schema was correctly applied. So I will again get rid of the lexical part just to see. Yeah, so we can see that the graph abides by the schema that we defined and it has a richer information. And overall, we still have the same chunks, but we have more nodes and relationship types that better represent the domain. So if we look, for instance, at the agreement nodes, now they should have the newly created relationship. So this Paris Agreement, for instance, node target this global warming event. Also, if we look at the renewable energy source nodes, we see that we also have the new relationship created reduces impact. We can also control the extraction by specifying some rules that are really specific to the domain. So let's say we use some abbreviations in this domain. So if we take the example of greenhouse gases that are created, we have this name property, but sometimes the abbreviation is used and sometimes the full, this is not a good example, but yeah, here the full name of the gas is created. So what we can actually do, this is just a dumb example, but just to show how we can control the extracted graph. So here, one way to do it is to use a custom prompt for entity extraction, or use the one that we have by default, but add additional guidance. So here, for instance, I add a new rule that we should use canonical short names whenever possible for greenhouse gases. We can also add other rules that are really very specific to the domain. So this is mainly it. Let's see if that was correctly applied. So yes, we do have these domain-specific abbreviations that were created correctly. So yeah, this is what I wanted to show. So yeah, handing over to you, Estelle, for the second part of the demo. Thank you.
Thank you, Natalie. So let's go again with the notebook. So a few things that we want to demo again, a bit of more advanced feature. The first part is this simple KG pipeline. So you can run it by instantiating all the components as Natalie has shown. You can also run it by defining everything in a config file. So for instance, here we have a YAML file that shows all the different configuration from how you will instantiate the neo4j driver, how you will instantiate the LLM, and so on. And here we also have the schema that Natalie has shown with all the different entities. And you can also configure some of the components. So I'm going to run this, and the only difference compared to what Natalie has shown is that I'm going to disable the automatic entity resolution that is normally performed at the end of the pipeline. And we will dig a bit deeper into this entity resolution step and understand how we can configure, what we can change, what it is doing. So the pipeline is finished. So we are going to see what we have in the graph at the moment. So as you can see, since we have totally disabled entity resolution, we have chunks here, those, I don't know, gray nodes. They are totally disconnected from each other. So we haven't resolved or merged any entity coming from those graphs. So you can see, for instance, here we have a CO2 node, we have another one here, and they are totally disconnected. What I'm gonna do also just for the demo purpose is I'm going to create a few other nodes. And you see here, we have one nitrous oxide node. I'm going to create a few other nodes with synonyms, basically, of this gas. And what we're going to do next is to use the spaCy semantic resolver. That uses semantic similarity to merge nodes with similar names and the same label. We are not merging nodes with different labels. And so if I rerun and I check again what we have in the graph now, you see that now we have a way better connected graph. We have only one CO2 node that has been merged. And we should also have only one dinitrogen node. So those are the relationship that I created manually earlier with the connection to Greenland and Japan. And the connection here to the chunk, for instance, is the one that was already extracted in the graph. So yeah, entity resolution is the important step that goes after the graph. So you can, the one that we use by default is in the pipeline is an exact match on the name property of each node. But if you want to run something a bit more complex, a bit more use case specific, you can totally disable what we are doing or keep it and run your own entity resolver process at the end. The other thing that I want to mention is in our resolvers, we have the ability to use a filter query. So by default, all the entities in the graph, so all the nodes with the entity label are considered for merging, so can be merged during this process. If you want to reduce the amount of nodes that can be considered as candidate and be merged, so part of your graph, for instance, is something that you trust and you do not really want to arbitrarily merge with other nodes, you can use this filter query to choose the nodes that will be merged. For instance, here we are importing data from Wikipedia, so we added this metadata field to the document. So you can select, you can decide to merge only the entities that come from Wikidata. If you have, on the other end, ingested some data, some company data with another source, they won't be affected by this merge. All right, and the last thing that we want to demo is how you can create your own component. So we are saying since the beginning that you can do that. So what I'm going to show you now is how you're going to do this. So in our default pipeline, we're reading PDFs and we're splitting them with a fixed size length. And so in this case, we have some Wikipedia articles, so they have some structure, and it would make more sense to split them by section. That's what we can think of. So we are going to build our own loader and our own splitter so that we can perform that. Why our own loader? The thing is we are going to export our data as Markdown instead of raw text. And for that, we are using this new PDF for LLM module here, and just using it here to extract the text to Markdown. So it's a simple line. And then our data loader component needs to return a PDF document with some text and also some document information, so the file path and some metadata that will be added to our document node in the graph afterwards. And then, so this text will be passed to the next component, which is the splitter. And again, here we just have implemented a very simple splitter based on the header. and it needs to return some text chunks. And once we have our components, basically we can test them and see how they work. So we can run them standalone, let's say, and we can also run them within the pipeline. And I can actually clean up my graph so you can see the final results. And so it takes a few seconds to run this pipeline, and you'll see the result. So in the meantime, I just want to mention so that basically this text splitter and data loader here are interfaces. So the run method signature is something that is fixed so that the pipeline knows what it's expecting and what it's returning. So that's the only thing that you need to obey to. All the rest inside those run method is totally up to you, and you can implement what you want. And so if now we check what's in this graph, so it's very similar. The only difference is we have a bit more chunks because we have 13 sections instead of 8. And then all the rest is very similar. We have run the entity resolution, as you see, so we have only one CO2 node. And yeah, that's it about the demo. And just wanted to share some thought about some concluding thoughts. So there are 3 components that you can customize within the pipeline. So the splitter and the loader are the 2 components that I've just demoed. You can also update the writer if you want to write the data in some different way or to do some, I don't know, some very custom behavior for the writer. You can also customize this. And those are the components that you can run, so either within the pipeline and that you can also run outside of the pipeline if you want to tweak things a little bit. So the schema builder that Natalie demoed, you can either define your schema manually or you can use some LLM to extract the schema. And we also have a component to extract the schema from an existing database if you already have a data model that you want to reuse. And we have those entity resolvers that you have just seen. So I demoed the semantic match with a spacey. We also have a fuzzy match, if that's more interesting for you. So yeah, I hope you enjoyed. So we have demoed this open source package for KG construction with a lot of customization. So it's open source. You can, of course, submit PRs. If there are some features that you think are missing, do not hesitate to reach out, and we'll be happy to review and help you contribute. And I think with that, we're done with the demo. Do we have a bit of time for questions, or are they all answered in the chat?
I think we answered them all. Just checking now. Yeah, I think that's it.
Well, in that case, thank you, everyone. Thank you for the interesting questions.